Okay, this is the video solution for problem number 2 of the lab section 54. Okay, this was on a midterm. So the problem that's given to you is like so. The side view is shown here. As soon as you see that, you realize that it has to be done with shell elements. Okay, so the most appropriate element is the shell element. That's what you should be using. The other thing is that these thicknesses are different. The thickness on this side, this is zero point 0.2, down here is zero point 0.1. Furthermore, the edges of these holes are clamped, A and B are clamped, and you apply a total force of 50 pounds on that circular edge of the hole C. You're asked to use all planes of symmetry, and it doesn't take much to see that you can cut this thing vertically, and you do on either the right side or the left side and solve the problem. There's only one plane of symmetry and cutting it like that. So if you look at this coordinate system, for example, the YZ is a plane of symmetry. Now, you have two choices. You can make this thing and cut it into half, or you can make it exactly like it is. Sorry, you can make only half of it. I'm going to go that second route. Okay, so let's go here. We start with a part file. Okay, and immediately I'm going to save this thing, file, save management, save as, on my desktop, create a new folder, and I'll call this thing midterm lab 54, problem 2, and it is a shell problem. Okay, and save it. Okay, since I'm going to be making surfaces, I have to be in generative shape design. So on that plane, I will sketch. I'll make two quarter circles. We do it like this. You can make it any way you want as long as you get the correct geometry. So this is how I'm going to do that. So this one, okay, and that one. Okay, so if this, for example, is the one that is that quarter of a circle, exit, fillet, F-I-L-L, okay? Now on that plane, a few minutes ago, in other words, I'm going to draw a circle here. The distance from the, let me also draw a line from here to there. I'm going to delete that line in a few minutes. You'll see why I need it. Okay, so the dimension of that line is 3 inches. 3 inches, because that's how much the center of the circle is away from the origin. And this angle is 30 degrees. That's the only reason that I made that line, really, to create this angle. That's all. I don't need it anymore. So I'm going to delete that. I'm going to delete that line in a minute. And the radius of the circle itself is 0.5, or diameter is 1. Okay, so what we're going to do is, I don't need this line. If you want, you can leave it there, but I'm going to delete it. Okay, exit, and then use a split that surface with that circle, and there we are. Okay, so what I did is actually for you to construct this piece. I constructed this piece. Now I need the bottom one. So what I'm going to do is we'll keep this thing, but on that same plane I will sketch another sketch. Okay, the bottom one. So we do exactly the same thing, namely, for example, we can do a quarter of a circle, exactly the same thing, from here to there. Okay, close this, just like we did before, and close that. Okay, these radii are going to be the correct radii, so we're going to exit, and we're going to fill it, F-I-L-L. There we are. Now on that, we're going to sketch that little circle. The little circle is this one, half a circle. Okay. So let's put this thing there. So for example, something like this. Okay. I didn't close that. So this control that, we make it coincident to close it. Okay. Now let's draw that line here because uh, cut it, right? Cut it with this. Okay, let's put some dimensions. The distance from the center of this to there is again 3 inches. The distance from here to there is 3 inches. The position angular position is correct, and this is radius 0.5. 0.5. Okay, and this is it. So exit, and cut it, split this surface with that. Okay, now because of the way I did this thing, I created 2 surfaces. You're gonna have to join. You have to join. You have to join. There. Join this with that. Okay, because I don't want to have duplicate nodes on this line, etc. So now we're gonna go and exit. Oh, material. Let's apply material to this. Everything is made out of steel. Okay. We save everything. Now we're going to go to generative structure analysis. We're going to use shell elements to mesh. Because we joined it, it's going to do it at the same time for us, both C pieces, and there won't be any, seam basically over there. So let's make this thing a little bit smaller, maybe 0.3, see how it looks like. Yeah, okay, that's good, that's good. You want to see the mesh, right? Click mesh visualization. And you will notice, let's change this. You will notice that because we joined this thing and there is a line there at that interface. Where is that? Let me show you here. Let's bring this thing into the show mode. There it is. You see this? On this line, the nodes match from the 2 sides. See that? This white line over here? See that? The nodes are all on it. Okay, good. Let me hide this. Okay, deactivate the mesh. Okay, now thickness. This guy, that one has a thickness of 0.2, the bottom one has a thickness of 0.1. So what we're going to do, we're going to make everything 0.2 because we joined it, it's going to take it. And then we're going to say, oh, I want a local mesh, local 2D property on this, or this. I don't want this thing to be 0.2, I want it to be 0.1. And we say, okay, so this has 0.2 thickness, this has 0.1. We don't want these things, we're going to hide them. Incidentally, let me delete anything that not delete, but hide anything that I don't want. I don't want these sketches. I'm hiding it. I don't want this, although it doesn't bother me. I don't want this circle. Okay, very good. All right, let's save this. File, save management, analysis, save as. And this is the right folder, Lab 54. Okay. Okay, so what do we know? First of all, this edge is clamped, so we're going to clamp it. This edge is clamped. See that? It is clamped. Okay, very good. On this edge, there is a force acting, but that force is half of this, 25 pounds. Okay, because we're modeling only half of it, 25 pounds. So force on that edge in the direction Z, negative 25. Make sure you delete whatever was already there before, from before. You say, okay, you can see that. See, that edge is, you apply a force of negative 25 downward. And oh, these things are in planar symmetry. See that? These three edges, this edge and that edge and that edge, they lie in the YZ planar symmetry. So we know how to handle that. These three edges, namely this edge, and that edge, lies in the YZ planar symmetry, does not move in X, and rotations are exactly the opposite. And we say, okay, and we're going to save this. And that's, yeah, I don't know whether I saved it or not, but there, I ran it, basically. Okay, fine. Let's also save it, in case. Okay, let's look at the deflection. Yeah, that's what you expect. This is a planar symmetry. This is very thick. It doesn't move that much. This is flimsy. It does move. Okay, you can look at the stress distribution. And of course, because of that seam, there is a difference in thicknesses. You know, there is some stress concentration there, etc. But that's pretty much it. So let me stop this.